Hi friends, welcome to AMG World. Here I am with a mechanical topic which is related to IC engines. Here is our topic, basic, engine terminology. Basic engine and terminology. What is engine terminology and what the particulars comes under this particular engine terminology? So this topic contains some basic things like the definition of TDC, BDC, and swept volume, clearance volume, stroke, bore, engine displacement, power, and engine torque, indicated power, brake power. All those things all those things comes under this particular terminology. For understanding this particular topic, we should go through the construction once again. So here is the engine cylinder. Here comes the engine head, and here we have a piston which is reciprocating in this particular cylinder. Here comes the connecting rod. Here comes the connecting rod, and this connecting rod is going to get connected with crankshaft via a pin is called crank pin. So here comes the TDC, and here comes the BDC. So what do you mean by TDC? So what is TDC stands for? TDC means top dead center. Top dead center. What do you mean by top dead center? This means the maximum point, the maximum upper point which can be reached by the piston during its reciprocation is called top dead center. And BDC means bottom dead center. So the name itself saying that the maximum, the lowest point in the engine cylinder that can be attained by the piston during its reciprocation is called bottom dead center. And then next particular comes, what is bore? So the bore means, this one is, we are seeing this one as a rectangular section, but if we see this particular one in top view, this one seems like a circle, right? A circle. If we see from top dead center, so from top view, what happens, this particular section we can see as a circle. And so this is a engine cylinder. It's a cylinder structure. When we see from the top side, what happens, we see a circle, right? In this particular cylinder, this piston is going to reciprocate. So here comes the bore. The diameter of this particular cylinder is going to consider as engine bore. So here comes the next particular comes, we have the maximum point here, TDC, right? Here comes here this surface is just below, just bottom portion of the engine head, right? From here to the piston, from here to here, the piston, these two points, in between of these 2 points the piston is reciprocating, which means this one we can consider as stroke. So the distance between TDC to BDC is taken as stroke, right? So in between of these two dead center, what are these? These are dead center. the piston is never going to cross these centers, right? In between of these two dead centers, the piston is going to reciprocate during its working or functioning. And here comes the another one. This is a volume, right? This is a, we can see as a rectangle section here, but it is a cylindrical section. Cylinder containing a volume pi r square and h multiplied by h will gives us the volume of this particular engine cylinder. So here comes stroke volume, which means the volume which can be swept by the piston during its reciprocation, right? During its reciprocation, the volume which can be swept by the piston is considered as swept volume. Here comes the another thing. There is a gap here. Look at the space between this top dead center and the just bottom portion of the engine head. This one is the engine head, right? So this is the gap. Actually, this gap is provided for every engines. So this gap is called as clearance volume. So clearance volume. So the gap which is present between TDC to just bottom portion of head is called clearance volume. And we go to the bore. This is the swept volume and clearance volume, and stroke, TDC, BDC. And next we have power. So indicated power, and we have crankshaft comes here, right? So brake power, another one, brake power. Before going to these two particulars, we should have to know what is power. So what is power? Power is denoted by P. Power, it's a ratio of work to time. Which means here we can observe one thing, that power and time. So power is directly proportional to work, right? And inversely proportional to time. Here we can say one thing, that if time increasing for doing a specific work by a machine, if time is increasing, which means that particular machine having less power. If I take an engine, right? If I take a 100cc engine, right? If the 100cc engine having some n watts of power, and it is completing it's completing some newtons of work, some newton meters of work in t seconds, which means if power more, the time taken by the engine is going to reduce. And here look at the thing, power and work are both directly proportional. If power is increased, what happens? The work done by that particular engine or machine is also going to increase. If power increased, then the time automatically reduces. So here comes the concept of power. But here we have two kinds of powers. One is indicated power. Indicated power means the power which is available in the engine cylinder during its combustion stroke, right? During its combustion stroke, the power which is available here is called as indicated power. Power available in engine cylinder is called indicated power. Brake power, the power which is available at crankshaft. The power which is generated during the combustion stroke, the power which is available at the crankshaft, having much difference, which means the indicated power is going to through some losses, like thermal losses and frictional losses. There are several kinds of losses. After going through those losses, later we will have the power at its crankshaft, at engine's crankshaft. So the term the brake power says that the power which is available at the crankshaft is called brake power. So next we have engine capacity. So engine capacity. If we take, this is an inline engine, we are seeing front view of engine. We have series of engine of this particular cylinder's backside. So then here, if this one is with the stroke volume of n meter cube, so here comes n. So this engine capacity is the overall capacity of the engine including all cylinders, and we can find it by using a formula which is Vs into number of cylinders. So the total capacity of the engine says that engine capacity by including all the cylinders volume, all the cylinders of swept volume. So here comes the other thing, compression ratio. So compression ratio is denoted by R. And what is compression ratio? Compression ratio means the engine, how effectively it compressing the charges, right? So we can find this particular one by using a formula which is Vs plus Vc by Vc. This is the formula for compression ratio. So these are the particulars which comes under engine terminology. I hope this video is understandable and this video is going to be useful for you. I hope that this video is going to be useful for you people. Thank you for watching. Stay tuned to AMG World. Do subscribe to the channel and click on the bell icon to have updates. Thank you for watching.